So yes, my name is Joe. I'm a mobile engineer here at Octopus, and I work on the Octopus Electroverse app. I'm going to be sharing with you a little bit about how we use Kotlin Multiplatform to build apps for not only mobile, but also car. So I'm sure many of you will know a little bit about Octopus Energy already, but unless you drive an electric vehicle, you may not have heard of Octopus Electroverse. So our goal is to build the biggest and best public charging network for EV drivers. And to do that, we need to meet our users where they are. And often for us, that means in their car. So around a year ago, we launched apps for Android Automotive OS, Android Auto, and Apple CarPlay, building on top of a multi-platform architecture we use for our mobile apps. So in this talk, I'll be covering a bit of background on our journey with Kotlin Multiplatform. We'll be looking at how we use it for development across mobile and car, and an example of what this looks like on Android Auto and CarPlay. So our journey with Kotlin Multiplatform started in September 2020 with our initial commit to the Electroverse project. And it was a pretty bold commit. For starters, Alpha 1 of Compose 1.0. So a bit risky, and there's been some bumps along the road, but overall this has worked out really well for us. So Compose has matured into Google's recommended toolkit for building UI on Android, and we're 100% Compose, so no legacy layout XMLs for us. Similarly, perhaps less innocuous but equally daring, we're using Kotlin Multiplatform in version 1.4.0. So you may think 1.4.0 sounds pretty stable to me. Well, Kotlin Multiplatform didn't actually go stable until over 3 years later in version 1.9.20. And in a way, it still feels like fairly early days for Kotlin Multiplatform, with some exciting changes and improvements coming up in 2024. Including Kotlin to Swift support, which is likely to bring some nice improvements to the developer experience on iOS. So obviously, adopting these tools from an early stage hasn't been without its challenges, but we've grown to love Kotlin Multiplatform, and others are loving it too. So here's just a couple of real-world success stories of some pretty large companies using Kotlin Multiplatform to build apps that are used by millions of users worldwide. And it's also worth mentioning that although this talk is primarily focused on the Electroverse app, the main Octopus Energy app with over 2 million monthly active users is also using Kotlin Multiplatform in a similar way. So yeah, it's been proven to work at scale. So why is Kotlin Multiplatform gaining traction? Well, one reason is because, in my view, is because it's suitable for all sorts of projects. So it's a flexible option for cross-platform development. You don't need to go all in, and in fact, you can use it as sparingly as you wish. So for example, prior to joining Octopus, I worked on a project where we were using Kotlin Multiplatform for a small self-contained piece of business logic. And then on the other end of the spectrum, with the advent of Compose Multiplatform, some are now using Kotlin across the full stack of their multi-platform apps. On Electroverse, we've opted for a middle ground. We're sharing as much logic as possible, but keeping the UI native. And we kind of view this as the best of both worlds. So one of the key questions when evaluating a cross-platform tool is how do we implement platform-specific logic? So in Kotlin Multiplatform, we have a couple of options, which start off with the expect and actual mechanism. So in our common source set, in the Kotlin Multiplatform module, we say that we're expecting an implementation of this function within the source sets for each platform. So this allows us to use Android and iOS platform APIs within the Kotlin Multiplatform module. So for example, here we are using UIKit, which is a native iOS framework within Kotlin code, which can be quite a novel concept if you've only worked on purely native projects. For more complex scenarios, it can be more convenient to use platform-specific implementations of an interface. So to do this, we can define an interface in the Kotlin Multiplatform module. then define implementations in the app modules. So on iOS, the implementation will be in Swift rather than in Kotlin. So this is generally the approach we use on Electroverse for platform-specific logic, and particularly when we're using Swift-only dependencies on iOS, as these are not yet supported in Kotlin Multiplatform. So moving on to architecture, there are 101 ways to architect a mobile app. We've chosen to follow a clean architecture, which is strongly inspired by Google's Guide to App Architecture. And although this guide is Android specific, we find it works really well in a multi-platform project as well. So in a nutshell, we have a data layer who determines how our app creates, stores, and changes data. Our domain layer sits between the UI and data layers and is responsible for encapsulating our business logic. And our UI layer's role is to display the application data on the screen. So for us, the data layer, the domain layer, and the view models all live within a Kotlin multi-platform module. We call this our shared layer. So we're left with a thin layer of UI, which is kept native on each platform. And this approach works really well for us. We have a relatively small team of mobile engineers who are able to deliver features end-to-end across multiple platforms. Also, sharing a large percentage of our code base helps us to ensure we have consistent business logic across platforms while still enabling us to build UIs which look and feel great on each platform. So taking a look at our project structure prior to adding car apps, and it starts off pretty straightforward. So we have a Kotlin multi-platform shared layer where the bulk of our code lives. Then we have app modules for Android and iOS where our thin UI layer lives. So what happens to all of this when we add car platforms into the equation? Well, initially our plan was to pretty much keep the same thing. So we add a new app module for Android Automotive OS, as that is a standalone app. Android Auto and CarPlay are embedded in the Android and iOS app modules. However, there's a few things we need to consider when building apps for car. So most importantly, as developers, we must avoid driver distraction at all costs. So this is quite a different paradigm to mobile, where many apps are kind of built to be distracting. And this is semi-enforced by requiring developers to use templates for their UI. So in our case, we use the navigation templates. There's also a requirement that app developers keep task flows to 5 steps or fewer. And this is enforced by the runtime, at runtime by the SDK. So if you go over this, the app will just crash. So yeah, not great. If we want to enable, as an example, if we want to enable users to search for a location, find a nearby charger, view information about that charger, navigate there, and start a charge, we need to do this within 5 steps, which presents a bit of a UX challenge. So given these restrictions, the user experience pans out to be quite different to the mobile app. And our initial plan to share view models between mobile and car just didn't really work out. And also, there's a few cases where it's beneficial to have car-specific implementations of our interfaces. So this led us to breaking down our shared module into sub-modules, allowing us to separate concerns between mobile and car. So we have shared mobile, a Kotlin multi-platform module where we have our mobile-specific code, and then shared car, which similarly is a Kotlin multi-platform where we have our car-specific code. So what does this end up looking like for the car apps? Well, if we start by focusing on Android Auto, so we have a screen, which is kind of analogous to a fragment or a composable destination. A screen has lifecycle methods like onCreate, which will be familiar to Android developers, but it also has an onGetTemplate function in which we use template builders to define our UI. So note here, we've injected our view model, which is imported from the shared car module. So expanding on this a bit, so we consume a view state from said view model to build a list of locations which we'll show in the template. Switching over to CarPlay, things are very similar. We inject the same view model that we're using on Android Auto. We then consume a view state to create items for a list template. So lots of similarities between the two platforms. So moving over to the view model, which lives in the shared car module. So this essentially maps a flow of data that we're getting from a use case in the shared module to something that the car UI can display. So we try to keep this view model layer quite thin, with all business logic, networking, persistence, etc., done in the shared layer, which is shared across both car and mobile. So looping back to our architecture, even with these additional mobile and car modules, we still benefit from having a large majority of our code base shared between all platforms. So obviously, I've just scratched the surface here, but hopefully this has given you a taster of what it's like to use Kotlin Multiplatform. It's made it possible for us with a relatively small team to build products across multiple platforms, with possibly more to follow. So who knows, maybe we need to update this graphic soon. So in summary, we covered a bit of background on our journey with Kotlin Multiplatform. We looked at how we used it for development across mobile and car platforms, and we looked at an example of what it looks like for Android Auto and CarPlay. And I can't wrap up without a shout out to Antonio, who's based in Germany, so he couldn't be here. So Antonio's been the brains behind our Android car apps, and I know he'd love to connect if you have an interest in building apps for car. And what I should have mentioned also is Jack, wave Jack, similarly is the brains behind our CarPlay app. So yeah, again, get in touch with him if you have an interest there. Also, a couple of useful resources. So starting off with TouchLab, who have a whole bunch of useful stuff around Kotlin Multiplatform. So sample projects, blogs, open source libraries. So I recommend taking a look at their website. John O'Reilly is a Google developer expert for Kotlin, who has a keen interest in Kotlin Multiplatform. So he has a number of really good sample projects as well. And finally, a link to an Android Code Lab for learning how to build apps for Android Auto and Automotive OS. PS, as Alex said, we're hiring across various teams and roles. So if you're interested, head to the website or speak to Michael. Is Michael here? Michael's somewhere. Yeah, that's it. That's me. Any questions?